Hello, welcome to the course CE 409, Simulation and Modeling. I am Dr. Muhammad Naseem, Assistant Professor in Department of Software Engineering. Now I am describe the queuing models. Outline of the today lecture is Queuing models purpose, general characteristics of queues, calling population, system capacity, arrival process, queue behavior and queue discipline, service times and service mechanism, queuing notation. Queuing theory is the mathematical study of waiting lines, or queues. A queuing model is constructed so that queue lengths and waiting time can be predicted. Queuing theory has its origins in research by Einar Kara-Perlang, when he created models to describe the Copenhagen telephone exchange. The ideas have since seen applications, including telecommunication, traffic engineering, computing and, particularly in industrial engineering, in the design of factories, shops, offices, and hospitals, as well as in project management. Queuing models, typically measures of system performance, server utilization, length of waiting lines, and delays of customers. For relatively fairly simple systems, compute mathematically. However, for realistic models of complex systems, simulation is usually required. Characteristics of queuing systems. The key elements of a queuing system are the customers and servers. Customer refers to anything that arrives at a facility and requires service, like people, machines, trucks, emails. The term server refers to any resource that provides the requested service, like repair persons, retrieval machines, runways at airport. For example, if repair persons repair the broken machine, where broken machine refer as a customer, and the repair persons treat as a server. Another example is doctor-physician treats the patient, where patient is customer, and physician is server. Calling population is one of the characteristics of queuing system. It is defined as the population of potential customers may be assumed to be finite or infinite. Infinite population model. If arrival rate depends on the number of customers being served and waiting. For example, model of one corporate jet. If it is being repaired, the repair arrival rate becomes 0. In infinite population model, if arrival rate is not affected by the number of customers being served and waiting. For example, a bank or restaurant system with large population of potential customers. The main difference between finite and infinite population models is how the arrival rate is defined. In an infinite population model, arrival rate is depend on the number of customers being served and waiting. And in an infinite population model, arrival rate is not affected by the number of customers being served and waiting. Another characteristics of queuing system is system capacity. It's a limit on the number of customers that may be in the waiting line or system. This can be limited or unlimited. Example of limited system capacity is automatic car wash only has room for 10 cars to wait in line to enter the mechanism. Example of unlimited capacity is concert ticket sales, with no cap on the amount of people required to wait to purchase tickets. The next characteristic of queuing system is arrival process. The arrival process of customers to the service system is classified into two categories. Number one is arrival process for infinite population model and second one is finite population model. In infinite population model, arrival may occur at scheduled time or at random times. In case of random time, inter-arrival times are usually characterized by a probability distribution. The most important model for random arrivals is the Poisson arrival process. The Poisson arrival process has been employed successfully as a model of the arrival of people to restaurants, drive-in banks, and other service facilities. A second important class of arrivals is scheduled arrivals, such as patients to a physician's office or scheduled airline flight arrivals to an airport. A third situation occurs when at least one customer is assumed to always be present in the queue, so that the server is never idle because of a lack of customers. For finite population models, the arrival process is characterized in a completely different fashion. Define a customer as pending when that customer is outside the queuing system and a member of the potential calling population. For example, a tire curing machine is pending when it is closed and curing a tire, and it becomes not pending the instant it opens and demands service from the worker. One important application of finite population models is the machine repair problem. Times to failure for a given class of machine have been characterized by the exponential, the QueueingModel, and the gamma distributions, which are mentioned in the previous chapter. Process queue behavior and queue discipline is also a characteristic of queuing system. Queue behavior refers to the actions of customers while in a queue waiting for service to begin. Queue discipline refers to a customer ordering in a queue, which customer is chosen for service when a server is free. Common queue disciplines are: the first discipline is FIFO, it means first in first out. And next discipline is LIFO, it means last in first out. And another discipline is SIRO, it means service in random order. And the second last discipline is SPT, it means shortest processing time first, or SJF, it means shortest job first. And the last one PR, it means service according to priority. The last characteristic of queuing system is service times and service mechanism. The service times of successive arrivals are denoted by S1, S2, S3, etc. They may be constant or of random duration. It is usually characterized as a sequence of independent and identically distributed random variables. The exponential, QueueingModel, gamma, log normal and truncated normal distributions have all been used successfully as models of service times in different situations. In some systems, service times depend upon the time of day. Or in some systems, service times depend upon the length of the waiting. A queuing system consists of a number of service centers and interconnecting queues. Each service center consists of some number of servers, working in parallel. Parallel service mechanisms are either single server, multiple server, or unlimited servers. Unlimited server is usually mentioned as a self-service. The next topic is queuing notation. For recognizing the diversity of queuing systems. In 1953, Kendall proposed a notational system for parallel server systems which has been widely adopted. Example 1. Consider a discount warehouse where customers may either serve themselves or wait for one of the three clerks, then finally leave after paying a single cashier. In Service Center 2, wait for one of the three clerks. Both service, or customer requires several servers simultaneously. Queuing notation. A notation system for parallel server queues is capital A/, capital B/, small c/, capital N/, capital K. A represents the inter-arrival time distribution. B represents the service time distribution. C represents the number of parallel servers. N represents the system capacity. K represents the size of the calling population. I hope that this lecture is useful to you. If you require any further information, please do not hesitate to contact me. My email address is mnaseem105@gmail.com. Thanks.